Hi guys, do you have an MTH 2205 final in 2 weeks, in 2 days, maybe in 24 hours? This video is made specifically for you. In order to ace MTH 2205, you need to know the following 300 plus topics. That's a lot of topics. But if you study them efficiently, even less than 24 hours study could dramatically improve your results. I'm going to focus on the following 10 most common topics that appear on Baruch MTH 2205 finals. Everybody procrastinates. It's absolutely normal. This is life. That's why we prepared a special last-minute cram course that will prepare you for your MTH 2205 final within a super short period of time. You can access our last-minute cram course by clicking the link in the video description below. Also, do not forget to subscribe to our channel and like our video. So let's do this. The first topic that we are going to cover is the Extrema. So we're going to take the specific problem number 2 from the final SP17. So the problem goes like this. Find the critical numbers of f of x when f(x) is equal to the square root of 4 minus x squared. So when we are talking about critical numbers, we always have to take into consideration two things. Critical numbers exist when the first derivative is equal to 0 or does not exist. What does it mean as a trick is you set the top of your derivative to 0 and then you set the bottom of your derivative to 0. It's very, very simple. So let's first of all find the first derivative. We cannot find the first derivative of this function itself because we first of all have to rewrite it. So if we are to rewrite this function, we're going to get f of x is equal to 4 minus x squared all to the power of 1/2. This is the rewritten function. Now we can take the first derivative. Here we have to deal with the chain rule, right? So the first derivative of f of x is equal to 1/2 4 minus x squared. Now the exponent is 1/2 minus 1, so negative 1/2, times the derivative of the inside. So it's going to be times negative 2x. The best way to simplify this first derivative is to rewrite every single element as a fraction. So here we got 1/2 times 1 over square root of 4 minus x squared. The reason why this is like that is because we are dealing with a negative exponent. So negative means that we place the whole thing to the denominator and then to the power of 1/2, meaning that's a square root, times negative 2x over 1. Now we can cancel things out and we get negative x over square root of 4 minus x squared. That's our first derivative. Now remember, the critical numbers exist when the top is equal to 0, bottom is equal to 0. So we are doing the top. Let's do the top and let's do the bottom. Right, so the top, negative x equals 0, and then the bottom is square root of 4 minus x squared equals 0. When negative x equals 0, it means that x is equal to 0. Boom, very simple. Now, when the square root of 4 minus x squared equals 0, what we can do is we can square both sides of this equation. So we get 4 minus x squared equals 0. Now move x squared to the other side, so 4 is equal to x squared. Therefore, x is equal to plus or minus 2. So we got x equals 0 and x is equal to plus or minus 2. So therefore we got 3 answers and the answer is D. The next topic is the first derivative test. We're going to take problem number 1 from the final test FA17. So here we are dealing with the absolute minimum for f of x equal to x over x squared plus 1. For the absolute minimum, there are a couple of steps. The first step is to find the first derivative, right? So let's, here we're going to be find the first derivative, f prime of x. Second thing will be setting that derivative to 0. Third thing will be to identify which points of the solution right here will fall between 0 and 2. 0 and 2 is the range presented to us by the problem. And then the fourth step is we plug in all of these points. So we plug in 0, we plug in 2, the endpoints, and we also plug in what are the points from step 2. Actually from step 3, right, after you got accepted. So all of these points we plug in back into the original function to find the lowest value. Minimum value of f of x means that what are the minimum value of y, and y is the same thing as f of x. So let me go ahead and erase the whole thing. So now we kind of know what the steps are. And I will just proceed with finding the first derivative first. Now, as you notice, as I'm still erasing, as you notice, we are dealing here with the fraction. Since we're dealing here with the fraction, we have to be using the quotient rule. So let's go. So here, the quotient rule goes like this. If we have f over g prime, the final result is going to be f prime times g minus f g prime over g squared. So here we have f equals 2x, g equals x squared plus 1, f prime equals 2, g prime equals 2x, and all we have to do is just plug it into this fraction. So it is going to be 2 times x squared plus 1 minus 2x times 2x all over x squared plus 1 squared. So that's equal to 2x squared plus 2 minus 4x squared over x squared plus 1 squared. So that's equal to, here we can cancel these two, right? So it's negative 2x squared plus 2 over x squared plus 1 squared. Now, it seems like we've done a lot of work, and we did, but this is just the beginning. This is just the first derivative, right? So that's just step 1. Step 2 is resetting that first derivative to 0. When we set in the fraction to 0, we're really just setting the top of this function to 0. So here we have negative 2x squared plus 2 equal 0. Let's move 2x squared to the other side. So here we have 2x squared equals 2, x squared equals 1, right? If you just divide that by 2, and therefore x is equal to plus or minus 1. So that's our step 2. So our critical values pretty much in this situation are plus or minus 1. Now the next step for us is to reject those critical values that are not in the region. They're not in the interval 0 to 2. So if you draw the number line, it has to be between 0 and 2. And our critical values are negative 1 right here and positive 1 right here. So we can definitely reject the negative 1, and we're sticking just with 0, 1, and 2. So let me just put it here. So 0, 1, and 2 are the critical values that we will be plugging into the original function. I'll just erase this whole thing for the sake of you guys seeing everything, right? And the final step is us plugging 0, 1, 2 into the original function, which is 2x over x squared plus 1. Okay? So give me a second. All right. I think we have enough space. So let's proceed. So here we have f of 0, f of 1, and f of 2. So f of 0 is I'm plugging x equals 0. So 2 times 0 over 0 squared plus 1. That's equal to 0 over 1, which is just 0. F of 1, I'm plugging 1 for 2. 1 for x. So 2 times 1 over 1 squared plus 1 equals 2 over 2 equals 1. And then I have to plug in 2. So it's 2 times 2 over 2 squared plus 1. That's equal to 4 over 4 plus 1. That's equal to 4/5. Now, we're looking for the absolute minimum on this region. Absolute minimum is 0. So the answer is B. Quite simple again if you know the rules. The next topic is concavity. Here we're going to be looking at problem 23 from the final of SP17. So here we need to figure out the graph of function y is concave downward whenever, and we are presented with the regions. So you're looking at the options immediately, and you know that we have to give some kind of range. In order for us to give some kind of range, concave downward, meaning we have to deal with the second derivative. So let's do the first derivative first. So f prime of x is equal to 4x cubed minus 18x squared plus 24x plus 4. And right away take the second derivative. F double prime of x is equal to 12x squared minus 36x plus 24. I know that 12, 36, and 24, they all have 12 as a factor. So I'll just factor 12 out, and I get x squared minus 3x plus 2. And then I'll further factor this equation out, which is 12 times x minus 1 times x minus 2. You can check it by following it back. Now, if I can set the second derivative to 0, I will get the following inflection points. 12 times x minus 1 times x minus 2 equals 0. It means that either x minus 1 equals 0 or x minus 2 equals 0. X minus 1 equals 0 means that x equals 1. X minus 2 equals 0 means that x is equal to 2. So these are our two inflection points. Now let's draw the number line, put the points 1 and 2, and start plugging the points. So if you plug in point x is equal to, say, 0, and where should we plug it in? We should be plugging it in back into the second derivative. The main trick in this situation is not to plug into, which most people do. Lots of people just plug into this. That's probably not the best way. The best way is to plug it directly into the factored form, right? So 12 times 0 minus 1 times 0 minus 2, which is the same thing as 12 times minus 1 times minus 2. So I know that this is positive immediately because negative 1 and negative 2 turn into a positive times 12. That's a positive number. So here it's a positive. And I know that they have to interrelate, like they have to be pretty much change. So plus, minus, plus. I am looking for the concave downwards, so I'm looking for the minus, and the minus happens between 1 and 2. So the answer is B. Next problem is the business applications problem. And for the business applications problem, we're going to take the test, the problem 3 from final FA17. So let's jump onto it right away. So here we have to find the average cost for the function c of x is equal to 2x cubed minus 20x squared plus 100x. And we have to find the value x that minimizes the average cost. In order for us to find that, we first will have to find the average cost. Then we have to take the first derivative of the average cost, so c prime of x, set that to 0, and solve for x. 2 steps. So what is the average cost? The average cost is your cost, so c of x with this whole dash thing, or bar, whatever, it's equal to 2x cubed minus 20x squared plus 100x, which is our cost, all over x. So here, let's just cancel the x's out, so this is just 2x squared minus 20x plus 100. That's the first step. Second step, let's find the first derivative and set it to 0. So, well, in this case, I'll do c prime of x dash is equal to 4x minus 20. And I'm setting this equal to 0, therefore x equal 5. And that's it. Very, very simple. The answer is A. Topic 5, linearization. After this one, we're going to be half done. So looking at problem 25 from the final SP17. A couple of steps here. So we need to linearize f of x near the point x equals 0, and then find f of point 12. Pretty difficult problem, but there are 4 important steps. The first step is find the first derivative of x. Second point is plug in f prime of x0. What is x0? This guy is x0. Third step is find f of x0. And fourth step is y minus f of x0 equal f prime of x0 times x minus x0. Looks like crap. Looks super complicated. But I gotta show this to you right now in a second how this is super simple. All right. So what makes it a little bit difficult though, all these steps, is the fact that we're dealing with a pretty complicated function f of x. It's the radical of 4 plus x, and that definitely makes things a little bit harder. But just like we saw in the previous thing, the first things first is rewrite f of x is equal to 4 plus x to the power of 1/2. This is key. So the first step is to find the first derivative. So f prime of x equals 1/2 4 plus x to the power of negative 1/2. What I would do immediately is I would rewrite this. So 1 over 2 times 1 over 4 plus x to the power of 1/2. So this is 1 over 2 square root of 4 plus x. That's what I would do right away. Now, the second step, remember, is f prime of x 0. In this case, x0 is equal to 0, right? Literally 0, right here. So f prime of 0. So I'm just plugging 0 for x. 1 over 2 square root of 4 plus 0, which is the same thing as 1 over 2 square root of 4, which is the same thing as 1 over 4. And this is also our slope, by the way. Let me change the colors just to make sure that I can show everything nice and clean. The third thing is to, oh, wait a second, let me change the colors. The third thing is to make sure that we can find the y value, corresponding y value. So I'm actually going back in slides a little bit here. Sorry for that, guys. Okay. So the third step is to find f prime of just f of 0. So I'm plugging 0 into x into the original function. So this is square root of 4 plus 0, which is the same thing as square root of 4, which is the same thing as 2. Now my final step is y minus f prime of y minus f of 0. So y minus 2, taking this 2, is equal to f prime of 0, which is our slope, 1/4, times x minus x0, which is 0. So y minus 2 is equal to 1/4 x, or y is equal to 1/4 x plus 2. This is our equation. We just linearized the function. Now, what is f of 0.12? F of 0.12 is us plugging 0.12 into x. That's equal 1/4 times 0.12 plus 2. So I immediately see that it's going to be 2, and this is going to be some weird decimal. So it's D's of the question, E's out of the question. So it's either A, B, or C. So what is 0.12 times 1/4? 0.12 over 4. 12 over 4 is 3. So this is just 0.03 plus 2 is 2.03. So it's B. So again, this problem is a little bit more complicated just because the original function was 4 plus x to the power of 1/2. Next, topic number 6 is the inverse functions. Actually quite simple. Not really calculus material, more like algebra material. We're going to take problem 14 from the final FA 17. So here we have to find the inverse for the following fraction. What do you do right away? The first step is to rewrite y equals 4x minus 1 over 2x plus 3. The second step is to flip x and y's. So x equal 4y minus 1 over 2y plus 3. What then you would do is you would say that x is really x over 1 and do the butterfly method. Butterfly method is just multiply, cross multiplication. So x times 2y plus 3 equals 1 times 4y minus 1. So 2yx plus 3x equals 4y minus 1. You have to solve for y, so what do? You group y terms together. So what I would do, I would move 4y to the other side. So 4yx minus 4y equals negative 3x minus 1. I would factor out y, so 2x minus 4 equals negative 3x minus 1. Boom, and now I would solve for y. So y is equal to negative 3x minus 1 over 2x minus 4. Let's see if we have this kind of answer. It seems like we don't have it anywhere, but what do you do in this situation? It's a fraction. So let's multiply both top and bottom by negative 1. Then in that situation, the top will turn into 3x plus 1, and the bottom will turn into negative 2x plus 4, which is the same thing as 3x plus 1 over 4 minus 2x. And now we see that the answer is D. Next, topic number 7. Almost done. Exponential functions. Here we're going to be looking at the problem 30, which is the calculator problem from SP17. So I will change the view a little bit here. So I will add the calculator right here, and we have to have a calculator. But before we do the calculator, we have to set up the problem. So let's read the problem. The population of any town was 100,000 people on Jan 1, 2016, and is growing at a continuous yearly growth rate of 4.5%. At what year will the population reach 200,000? The first thing, although it's a calculator question, you have to set up the equation. So we have to say that 200,000 is equal to 100,000 multiplied by 1 plus 0.045 to the power of t. And this is the equation that we have to solve. That's pretty much it. So on the calculator, let's type in solve F2, solve 200,000 equals 100,000 multiplied by 1 plus 0.045 to the power of t comma t. Boom, solve. So the answer is t is equal to 15 years, 15.74 years. 15.74 years. Now, right now we are on January 1st, 2016. So let's add 15 years, 15 to 16 years. So therefore, it's going to be anywhere between 2031 and 2032. So it's B. All right. Switching back to the normal mode. So here, topic 8, we're dealing with the derivative of e to the x. We're taking problem of 12 from final SP17. Here we have to find the first derivative of an exponential function. So again, let me change the colors just to make it all nice and exciting. All right, what do we know? We know that this 2 over x is not x, it's u. So if f of x is equal to e to the power of u, therefore f prime of x is equal to e to the power of u times u prime. Very, very simple. So in our situation, u is equal to 2 over x, which is the same thing as 2 times x to the negative first power. What is going to be its first derivative? The first derivative of u is going to be 2 times negative 1 x to the negative 2, which is the same thing as negative 2 over x squared. This is the derivative of u. So if f of x is equal to e to the power of 2x, therefore f prime of x is going to be, again, taking this e to the u, so e to the 2x times u prime. U prime is negative 2 over x squared. All right, so that's our answer. Which one is the one, right? The one, it seems like it's D. So let's move on to the next problem. Topic 9, logarithms. In the logarithms here, we have to deal with problem 18 from the final of SP17. So solve the following logarithmic equation for x. Log with the base of 2 of x plus log with the base of 2 of x plus 2 is equal to 3. Dealing with logs. Dealing with logs is very simple if you know the rules. Rules go like this. Log of a plus log of b will be equal log with the same base of ab, which is the product of ab. So here, log with the base of 2 of x plus log with the base of 2 of x plus 2 will be equal to the product of them. So log with the base of 2 of x times x plus 2, which is the same thing as log with the base of 2 of x squared plus 2x. Now we know that this thing is equal to 3. Boom. So 2 to the third power then is equal to x squared plus 2x. X squared plus 2x therefore is equal to 8. And x squared plus 2x minus 8 is equal to 0. This is the equation that we have to solve. This equation can be solved very simple. Just x minus plus 4 times x minus 2. You can double check that by FOILing. So x is equal to negative 4 or x is equal to 2. Now, c is out, d is out, e is potentially out. So it's either a or b. Lots of you guys will just pick a, and that's not right. You have to plug in negative 4 and 2 back into the original function because stuff under the logarithm has to be strictly greater than 0. So if you plug in negative 4, you'll get log with the base of 2 of negative 4. And right here you can reject the negative 4. Now what about 2? Log with the base of 2 of 2 plus log with the base of 2 of 2 plus 2. So both of these guys are greater than 0, so therefore x equals 2 is the answer, so it's B. Let's move on to the final topic. The final topic being derivative of logs. We're going to take problem 8 from the final FA17. We need to find dy dx. dy dx means the first derivative of this weird looking thing. So let's look at this weird looking thing and let's rewrite that weird looking thing first. How can we do this? We'll use the difference of logarithms. So this is equal to ln of square root of x minus 5 minus ln of 4x cubed plus 1. Right? Now, this dude right here, the square root of x minus 5, it's ln of x minus 5 to 1/2 minus ln of 4x cubed plus 1. And you can move the exponent at the front, so 1/2 ln of x minus 5 minus ln of 4x cubed plus 1. Now, if you take the first derivative of this, you know that the first derivative of ln u, everything prime, is equal to u prime over u. So if you take the first derivative of the first part, we're going to get 1/2. Derivative of x minus 5 is just 1 over x minus 5. Minus derivative of 4x cubed plus 1 is 12x squared over 4x cubed plus 1. And this is our answer. Now the most important part is to actually find it. It seems like it is B. Right here. So far so good. We were able to do 10 problems. Thank you very much for watching. We covered the top 10 most common topics that appear in Baruch MTH 2205 finals. Again, everybody procrastinates. It's absolutely normal. That's why we prepared a special last-minute cram course that will prepare you for your MTH 2205 final within a super short period of time. You can access our last-minute cram course by clicking the link in the video description below. Also, do not forget to subscribe to our channel and like our video. Thank you. Bye-bye.